Good day, students. Welcome to math.serve.com. In this clip, we're going to be going over problems 1 to 5 of the Algebra 2 New York Regents exam for January 2018. Alright, let's start out by taking a look at question 1. It reads, the operator of the local mall wants to find out how many of the mall's employees make purchases in the food court when they are working. She hopes to use the data to increase the rent and attract new food vendors. In total, there are 1,023 employees who work at the mall. The best method to obtain a random sample of the employees would be to survey. So we have four options here. Now, a tip to keep in mind is as follows. A good random sample of a population is a fraction of that population, as the word sample indicates. A sample of the population that is diverse and unbiased. Okay, so when you think about diversity, you want to make sure that your selection is spread as evenly as possible across the entire population. And when being unbiased basically involves not focusing your selection on a particular group of people that have a specific bias towards your desired outcome. Okay, all right, so let's take a look at these options right here and see which of these four alternatives best fit this description as to what a good random sample looks like. All right, so let's take a look at option 1. It says all 170 employees at each of the larger stores. So is this a good random sample? The answer is no. This is not a good random sample because of lack of diversity. Okay, there are larger stores and there are smaller stores, medium stores, but if you're just focusing on the larger stores, it's not diverse enough. Okay, so for option 1, only large stores um, is not diverse enough. You have to make sure you're selecting from the entire spectrum of stores, not just the big ones. Okay. Option 2, so 1 is no good. Option 2, 50% of the 90 employees of the food court. Is that a good random sample of the employees in the whole mall? The answer is no. What's wrong with that? Well, there could be a bias here apart from the small number. You work at the food court. What are the odds that you will eat where you work? It's very likely that people who work at the food courts will be very likely to eat there. Okay, so option 2 is not a good random sample. Why? Well, because sampling employees of the food court is biased. Okay, you want to try and make your selection as unbiased as possible. All right. Why is it biased? Since workers at the food court are more likely to eat there. Okay, and then apart from uh, it being biased, it's not diverse because you're just focusing on one geographical area in the mall, namely the food court, but you want to spread your selection across the entire geographical space in the mall. Option 3, every employee. Is this a good random sample? The answer is no. Um, every employee is not a sample. Okay, that's the whole. So every employee is not a sample. The reason why you get a sample is because you don't want to go through the trouble of surveying every single person. You want to look for a portion, as indicated earlier, a fraction of the entire population that will give you an idea of what the whole of how the entire sample space will behave. Okay, so every employee is not a sample, or you can think of it as a fraction of the population. Okay, of the mall's population. All right, let's take a look at the last option, option 4. Every 30th employee entering each mall entrance for 1 week. This is excellent. Why is this excellent? Well, first of all, take a look at which employees have been selected. There's no criteria associated with them. It doesn't, we're not looking at the employees working at a particular size of store or at a particular geographical location. Every employee is uh, every 30th is selected, so from the 30th from every employee. And another important thing is from each mall entrance. Okay, they're not looking at the entrance from one particular area, so this is the best random sample here. Okay, so it is diverse and unbiased. Okay, it is diverse and not biased because every, the keyword is here is every 30th employee from where? From each um, entrance. Okay, so you can get a nice spread of people to select for your interview. Okay, from each entrance is selected. So out of the these four options that we have here, option number 4 is the best random sample for this experiment. All right. All right, let's take a look at question 2. It reads, what is the solution set for x in the equation below? So we have the square root of x plus 1 minus 1 equals x. All right, so something you want to keep in mind concerning the solutions to radical equations, so something you want to recall is that has to do with radical equations. You always have to check your answers for something called extraneous solutions. Okay, what are extraneous solutions? Extraneous solutions are answers that you get while solving but do not satisfy the original equation. Okay, all right, let's go ahead and solve this equation. So we have the square root of x plus 1 minus 1 equals x. Okay, so the steps we're going to execute here are as follows. We're going to first of all isolate the radical, and then we're going to eliminate it by squaring both sides and then solve the resulting equation. Okay, so let me just itemize the steps here. So step 1 is to isolate the radical, and then step 2 is to eliminate. That's the objective of isolation, right? So you can eliminate it. So you eliminate the radical, and then finally you just solve the resulting equation. Okay, let's go ahead and execute this step. These steps start by adding 1 to both sides, and then that gives us the square root of x plus 1 equals x plus 1. So that's that with the isolation step. Next step is to eliminate the square roots by using the inverse of the square root, which is square. So you square both sides. On the left side, we have the composition of two inverse functions, so they take each other out, and we're left with x plus 1. And then on the right side, we have this quantity squared, so it's x plus 1 times x plus 1. Okay, now let's simplify. On the right side, we can distribute this. X times x is x squared. When you do your outer and inner, you have plus x, which adds up to 2x plus 1. Alright, now we're done with the isolation, with the elimination completely, and we've simplified. We're now going to solve this resulting quadratic for x. Now to do this, first thing we're going to do is place this equation in standard form. Okay, So what is the standard form of a quadratic? Well, it's the form where it's equal to 0 and we have descending degrees for the terms. Okay? So to accomplish that, we're going to subtract x from both sides of the equation and then subtract 1. And that's going to give us, I'm going to switch the equation around, okay? Alright, so that's going to give us x squared plus 2x minus x is just minus x plus 1 minus 1 is 0. So that's gone. And then on the right, on the left side, this whole thing adds up to 0. Now, how do we solve an equation like this? Well, we can factor. Let's factor out x. Well, plus 2x minus x is plus x. Right there. Okay, so we'll factor out x, and then we are left with x plus 1 equals 0. And then we'll now set both factors equal to 0 using the zero product property. The first one is already solved. This can be solved by subtracting 1 from both sides, and you have x equals negative 1. Okay? So are these the solutions to the equation? The answer is no. These can be classified as potential solutions. Okay, so our potential solutions are x equals 0 and x equals negative 1. Why are they called potential? Well, because one or both of them could be extraneous. Okay, that's why they're potential yet. How do we know if they're actual solutions or extraneous? To do that, we have to carry out our check. Okay, so the check involves seeing which of these solutions satisfy the original equation, root x plus 1 minus 1 equals x. Let's start with x equals 0. So just plug in 0 for the x's and see if we end up with a true statement. Question: the square root of 0 plus 1 minus 1, is it equal to 0? Let's see, 0 plus 1 is 1. Square root of 1 minus 1, is it equal to 0? Square root of 1 is 1. 1 minus 1, is it equal to 0? 1 minus 1 is 0. Is 0 equal to 0? Absolutely. So that means x equals 0 is an actual solution. Okay. Now let's test the next answer we got. X equals negative 1. The question is the square root of negative 1 plus 1 minus 1, is it equal to negative 1? Negative 1 plus 1 is 0, so is the square root of 0 minus 1 equal to negative 1? Square root of 0 is just 0. Is 0 minus 1 equal to negative 1? Is negative 1 equal to negative 1? It certainly is. So our actual solutions are the set of negative 1 and 0. Answer to number 2 is option number 3. Alright, let's take a look at question 3. It reads, for the system shown below, what is the value of z? Alright, so we have a system of 3 equations with 3 variables. So this is the plan of attack. Let's go ahead and write it down so you know exactly what we're about to do. What we're going to do first is we're going to find x. Okay, so how do we find x? Well, let's label the equations. This is equation 1, equation 2, and equation 3. The reason we're looking for x first is because this is the only equation that has z in it and has z and an x. So if we can know what x is, then we can find z. Okay, the other two equations just have x and y in them. So to do that, what we're going to do is we're going to use, so step 1, we're going to use equations 1 and 3 to find x. The method we're going to use is substitution. Okay, since y is solved explicitly for here, just substitute that in here and solve for x. After we find x, then we're going to use the result, from 1 to find z um, using equation 2. Okay? So as soon as we find x, we just plug in the value of x in equation 2 and we can easily solve for z. Okay, let's go ahead and put this plan to action and then you can see exactly what's going on. Alright, so part 1 of the entire process is looking for x. So let's find x. To do that, we're going to substitute. What are we substituting? Negative 2x plus 14 for y in equation 3. Okay, so we're going to have 3x minus. Now be extremely careful when you're substituting after a minus because the negativity causes signs to flip. So put the minus there and then use the parentheses for safety reasons to avoid making sign distribution errors. Okay, equals 16. Now you distribute this negative, imagine as though there's a negative 1 here, so you just distribute this negative to both terms in the parentheses. So you have 3x plus 2x, minus times minus is a plus, minus 14 equals 16. 3x plus 2x is 5x, minus 14 equals 16. You can add 14 to both sides, and then that yields 5x equals 30. Divide both sides by 5, and your final answer x is equal to 30 over 5, which is 6. Alrighty, so this implies that x is equal to 6. Alright, we're done with step 1 in our plan. Now we're going to advance to step 2, which is to look for z. Okay, to accomplish this, to find z, we're going to substitute the answer we just got. 6 for x where? Substitute 6 for x in equation number 2. Alright, if we do that, we're going to get 3 times 6 minus 4z equals 2. Alright, let's solve this. 3 times 6 is 18. 18 minus 4z is equal to 2. We can subtract 18 from both sides, and that yields negative 4z is equal to negative 16. Divide both sides by negative 4, and your final answer is z equals positive 4. Alright, so the answer to question number 3 is option number 4. Alright, let's take a look at question 4. It says the hours of daylight y in Utica in days x from January 1, 2013 can be modeled by the equation y equals 3.06 sine 0.17 x minus 1.4 plus 12.23. How many hours of daylight to the nearest tenth does this model predict for February 14th, 2013? Okay, so for this one, first thing we want to do is find the number of days from January 1st to February 14th, okay? So we have the function y of x equals 3.06 sine 0.017x minus 1.4 plus 12.23. So this is the deal. When we figure out the number of days from January 1st to February 14th of 2013, we're just going to plug that into the x. Okay, we're going to be using our calculators for this computation. So we want to find the number of days from when? From January 1st, 2013 to February 14. Okay? Alright, so let's do it. Well, it's easier to do it month by month. Okay, so let's do from January 1st to January 31st. Okay, so from January 1st to January 31st, because you're 31 days in January, right? Okay, so we're counting from January 1st. So from the 1st to the 2nd is 1. So if you count like that, you're going to have a total of 30 days. And then counting from January 31st, where we stopped, to February 14. So from January 31st to February 1st, that's 1 day, and then 2, 3, 4, all the way to 14, you have a total of 14 days. Okay, and then we just add it up. 44 days. Now, if this computation I just did doesn't make sense to you, just make yourself a little calendar. Just put the days down, and you should be able to count it accurately. Okay. All right. So, what's the hours of daylight? We're just gonna evaluate this function at 44. So y of 44 equals 3.06 times. We don't need the parentheses. 3.06 sine 0 0.017. Instead of x, you put in 44 minus 1.4 plus 12.23. Okay, so let's fire up our calculators and compute this. So we're going to have 3.06 sine 0.017 times 44 minus 1.40. So close the sign, and then we're going to add 12.23. And we have 10.3733. Okay, so it's approximately 10.3733 hours. So if we round it to the nearest tenth, or just one decimal place, y of 44 is going to be approximately 10.4. Okay, and the answer is option number 2. Alright, let's take a look at 5. It reads, a certain pain reliever is taken in 220 milligram dosages and has a half-life of 12 hours. The function a equals 220 times 1 half raised to the t over 12 can be used to model this situation, where a is the amount of pain relievers in milligrams remaining in the body after t hours. Question, according to this function, which statement is true? Okay, so these statements are basically assessing your ability to accurately evaluate output values using this function and the specified input values. Okay, so the first one, every hour, the amount of pain reliever remaining is cut in half. So starting with 220, after the first hour, a of 1, we should have half that amount, which is 110. Is this true or false? Well, we'll see. The second one, in 12 hours, there is no pain reliever remaining in the body. So this is saying, the claim here is that a of 12 is equal to 0. Uh, Option 3, in 24 hours, there's no pain reliever left in the body. So a of 24 is equal to 0. And then the last one, in 12 hours, 110 milligrams of pain relievers is remaining. So a of 12 is equal to 110. Okay? So the question is it, which of them is true and which is false? True or false? So we're going to have 3 false statements and 1 true one. The true one will be the answer. Okay? Alright, so let's enter the function. We're going to go 220 times 1 over 2 raised to the x over 12. So our independent variable here is x, okay? So 220, 1/2 raised to the x over 12. Now what we need is the table. Okay, so let's generate the table. Now you see that values are already provided for us. Um, so you can just scroll to see if it's right or wrong, or if you want to do it, if you want to jump right to a specified output with an input that you desire, you can reset the table format. Let's do that real quick. So I go to second function window. So for the independent variable, instead of it being automatic, I'm going to ask it to ask me for what input values I want to input so that it can tell me the exact output value. Okay? Alright, so I want to do 1, 12, 24, and 12. So let's do 1 first. So if I plug in 1, 207. If I plug in 12, 110, and 24, 55. So which statement is false, which is true? A of 1 is 207, which is not 110. A of 12 is 110, so it's not 0, it is 110. Oh, there we go, the answer. And A of 24 based on the calculator is 55. Okay? So this statement, this one is false. This is false. This is false. And this is true. Okay? So the correct answer is option number 4, because based on our input-output tables, when the inputs or T is 12 hours, there are, or you have 110 milligram of pain reliever left in the body. Alright, so that's that. Thanks so much for taking the time to watch this presentation. I really appreciate it. If you found the contents of this tutorial helpful in your preparation for the upcoming Regents exam, do give us a thumbs up. Your positive feedback is very valuable to us. Don't forget to subscribe to our channel for updates to the remainder of this review series. Questions or comments, you can just post it in the comment section below, and we'll be more than glad to support you. If you want to gain direct access to our playlist, you can just scan this QR code or click on the associated link. More tools and resources are available on math.serve.com. You can go ahead and check it out. Thanks again for watching, and have a wonderful day. Goodbye.